Hello everyone and welcome to UK Foundations. I am Uthara Adithi and today we'll be solving the acid bases and salts chapter long question and answers. So let's try completing this chapter, and I just thought of starting even the metals and non-metals chapter. So let's see if we can do it in this video itself. So in the previous video we had done the short question and answers, right? We are going to start up the long question and answers, so do check the previous video if you haven't. Okay, so long question and answers, 43rd one. In the following schematic diagram for the preparation of hydrogen gas as shown in the figure 2.3, what would happen if the following changes are made? Okay, so the apparatus is given. In place of zinc granules, some amount of zinc dust is taken in the test tube. Zinc dust are more finer. Okay, they're like this. If you see zinc granules, they are like this. Okay, so if you just apply a little bit of common sense, where will the reaction take place much faster? In this case, because it's much finer, and the reaction will take place much faster. So in place of zinc granules, if zinc dust is used, then the reaction is faster. Reaction becomes faster. Alrighty. Next, instead of dilute sulfuric acid, dilute hydrochloric acid is taken. So we have zinc. In place of H2SO4, you're using HCl. Okay, so we'll get ZnCl2 and hydrogen gas. So these are the products you can see. Okay, right. Next, if we in place of zinc, copper turnings were used. Copper turnings. Okay, in place of zinc, let's just keep copper plus H2SO4. Okay, this is going to give you might be like in much of excitation, you'll just write copper sulfate and hydrogen gas. You'll just write this, but this is wrong, right? See, if you remember the reactive series, you'll have below hydrogen, you'll have copper. Right, so will any reaction take place? Can copper displace something which is more reactive than it? No. Henceforth, no reaction. Okay. Next, sodium hydroxide is taken in place of dilute sulfuric acid and the tube is heated. So in place of H2SO4, you're using NaOH, Zn plus NaOH, which will give you Na2, ZnO2 and H2 gas. So this is called as sodium zincate. Okay, so sodium zincate is produced instead of sodium chloride if HCl is used, and sodium sulfate if sulfuric acid is used. Okay, so this question is done. Right. Next, the 44th question. For making cakes, let me just get some space. Okay, yeah, for making cakes, baking powder is taken. If at home your mother uses baking soda instead of baking powder in cake, okay, how will it affect the taste of the cake and why? See, basically you should use baking powder. Baking powder should be used. Okay, but baking soda, if it's used, what is the difference first of all? Okay, for baking soda, if you will add tartaric acid, some edible tartaric acid to this, if you add edible acid, which is tartaric acid, you will get baking powder. But if you're using only baking soda, what is the problem? Why can't we use it? So if you see baking soda, you'll of course heat it, right? After adding and all of that, you'll heat the cake in the oven. So on heating, what will happen is this NaHCO3 is going to produce Na2CO3, water and CO2. This is the problem. What happens is Na2CO3 is produced, right? What is Na2CO3? It's like basically dehydrated washing powder, right? This is yeah, so that is a base. It's a base, correct? This base is going to give you which taste? B for base, B for bitter. It gives you a bitter taste. So do you want your cake to be bitter in taste? No, right? So it will give you a bitter taste because of the formation of Na2CO3. How can baking soda be converted into baking powder? Yes, baking soda into baking powder is by adding edible acid. What is that edible acid? Tartaric acid. Tartaric acid. Okay, so what is the role of tartaric acid in adding to the baking soda? If you add tartaric acid, what is going to happen? Let's see. Okay, you can just write ki of course you're forming baking powder, which will enhance the taste and it will prevent a bitter taste in the cake. But let's see. In tartaric acid, okay, let's whatever, let it be, like whatever formula let it have, of course, because it's an acid, it will have H plus ions, right? These H plus ions, if you see, if you will basically what will happen is, how will this H plus ion be formed? On adding some water, right? It will dissociate to give the respective ions in the aqueous solution, so it gave H plus. Okay, this H plus ions, if you take with sodium carbonate, see, usually that NaHCO3 on heating, it will form this Na2CO3. So when this H plus and this Na2CO3 are going to react, they will produce carbon dioxide. So this carbon dioxide will give you a fluffy cake, and no more this product is formed, right? This product is converted into something else on adding this H plus ions. So it's no longer Na2CO3, but it's some other compound which is giving carbon dioxide and it's making your cake fluffy. Okay, so that's the role. Next, 45. A metal carbonate on reacting with an acid gives a gas. Okay, some metal carbonate on reacting with an acid gives a gas which when passed through a solution by gives the carbonate back. On the other hand, gas G, which is obtained at anode during electrolysis of brine, is passed on dry by. It gives a compound Z. Okay, so which is used for disinfecting drinking water. So it's two, this thing. See, the metal carbonate, let's see if it's calcium. Okay, the metal carbonate, calcium carbonate, on reacting with some acid, let's assume HCl, okay, gives a gas. You'll get CaCl2 and H2CO3, which will be unstable and gives rise to H2O and CO2, right? So this Y, which when passed through a solution, see, it's giving a gas which is CO2. This CO2, which when passed through a solution by, okay, gives the carbonate back. See, carbon dioxide, what is the test? Calcium hydroxide adding. So this is finally going to give calcium carbonate back. This is finally going to give calcium carbonate back, which is over here as well. Okay, so calcium carbonate is obtained back. Next, yeah, now gas G. On the other hand, gas G is obtained at anode during electrolysis. So what is obtained during electrolysis? Chlorine gas. Okay, that is obtained during electrolysis of brine when passed on dry Y. See, calcium, see, what is Y? It is this thing. Y on electrolyzing only, you will get Cl2. Okay, so when chlorine gas is passed on dry, dry calcium hydroxide, what you'll get the disinfectant, which is your bleaching powder. Okay, so what was S? X was calcium, Y was calcium hydroxide, okay, and G was chlorine gas, and Z is this one. Okay, next, okay, let's move on to the next one. Right, a dry pellet of a common base B, which when kept in open absorbs moisture and turns sticky. The compound is also a byproduct of chloralkali process. Identify B. What type of reactions occurs when B is treated with an acidic oxide? Write a balanced equation for one such solution. So see, it's a common base B, and if you know which base it is that absorbs moisture from the surroundings and turns sticky, usually there are some compounds which will absorb the moisture in the air and it will turn into something else. It will turn sticky because it has absorbed the water. Okay, so this is basically NaOH. It's a special property of it. Okay, So this is a base. So let's see its reaction with some acetic oxide. Let's suppose carbon dioxide. Okay, so you will get Na2CO3 and water. Na2CO3 and water is obtained. So we have to balance it. This reaction is known, right? NaOH with CO2 will give you Na2CO3 and water. So a balanced equation, they are asking 2 sodiums, only 1 sodium, just drop a 2 here. Oxygen is at balance, 3 plus 1 is 4, 2 plus 2 is 4, hydrogen is 2 and hydrogen is 2. Okay. A sulfate salt of group 2 element in the periodic table is white soft substance which can be molded into different shapes by making its dough. So this group 2 elements, amongst that, if you see this properties and which matches, of course calcium, right? This is calcium sulfate hemihydrate, which you know is also called as plaster of Paris. Okay, so now identify the sulfate salt and why does it show such a behavior. This is this, right? So this is a thing of plaster of Paris, right? It will like calcium sulfate, which when left in air, okay, it will absorb some water molecules and it's going to form gypsum calcium sulfate dot 2H2O, which is rigid, okay, which will be hard. Okay, this compound is formed which will make those molds to be hard. Okay, now the last question of this chapter, let's see. Okay, so identify the compound X on the basis of the reactions given below. Also write the name and chemical formula of A, B and C. Okay, here it's something to observe. Okay, so let's first observe and see. Zinc with some compound is giving you hydrogen. Okay, so if you think about X, should it be an acid or a base or something like that? If you see zinc with some acid, let's suppose if it's HCl, okay, then also hydrogen gas is produced. Okay, then zinc with some base NaOH, this is also producing some it's also producing hydrogen, so this can be an acid or a base with respect to this. Next, with HCl and with acetic acid, which is both are acids and both are yielding water, means this seems to be like a neutralization reaction for me, right? It's some neutralization reaction. So if both are acids, then this should be some base, which is confirmed now, right? So just take any base. Our common base that we use is sodium hydroxide, right? So let's use NaOH. NaOH with Zn will give you what? Na2ZnO2, Na2ZnO2, and here with HCl it will give you NaCl, and with acetic acid it's going to give you CH3COONA, right? CH3COONA. So this was the chapter, this is it. Okay, done. Let me just write it. Now we are going to see the metals and non-metals chapter. Okay, yeah, so let's see the metals and non-metals chapter. Here it is. We'll see the MCQ questions up to how much ever we can for today. Okay, how about some other color? Alright, MCQ questions. Which of the following properties generally not shown by metals? Not shown by metals. Okay, so electrical conduction, yes. Sonorous in nature, yes. Dullness, are metals dull? Are they dull? No, they are lustrous. They are lustrous and they are shiny, so it should be C, which is not shown. Ductility, yes, of course it's seen. Okay, the ability of metals to be drawn into thin wires is called as what? It's called as ductility. Malleability is to be beaten into sheets. Sonorous is to produce sound. Conductivity is to conduct electricity or heat. Okay, aluminium is used for making cooking utensils, right? Which of the following properties of aluminium are responsible for the same? Is it thermal conductivity, electrical conductivity, ductility and high melting point? Okay, let's just think, should it be electrical conductivity? We are going to keep the utensil on something, some fire, and what is the point of keeping electrical conductivity? Yes, we have some other cookers as well, but we are talking about the usual ones, so it can't be B. Remove those options with 2. Okay, it should be thermal conductivity, because it's of heat, so this or this. Next, ductility. What are we going to do with ductility of aluminium? If it can be drawn into wires, are we going to make cooking utensils with wires as such? No, right? So it shouldn't be even ductility and not even this. So it should be 1 and 4, which is fourth option. Okay. Next, which one of the following metals do not react with cold as well as hot water? Sodium, calcium, magnesium. These are good ones. They will react. Iron is the one that will react with steam. Okay. Yeah. Yes. Now, which of the following oxides of iron would be obtained on prolonged reaction with of iron with steam? For a long time, if you react iron with steam, which is water in gaseous state, you're going to get Fe3O4 actually. Okay, it will produce Fe3O4. Yes. What happens when calcium is treated with water? Calcium with water. Okay, it does not react with water at all. Nope, it does react. It reacts violently with water. No. See, sodium and potassium will react violently with water. It reacts less violently with water is true. It will react but less violently. Bubbles of hydrogen gas formed stick to the surface of calcium. The bubbles formed, here you'll get hydrogen gas, right? These are going to stick to the surface of calcium and it helps them to float. So 3 and 4. Okay. Yeah. Yeah. Generally, metals react with acids to give salt and hydrogen gas. Yes. Which of the following acids does not give hydrogen gas on reacting with the metals? Except for manganese and magnesium. This exception was given in your textbooks, if you remember. Let's just take some metal. Let's take zinc. Okay. Zinc with H2SO4 will give you ZnSO4 and H2. H2 is the given. Next, with HCl it's going to give you ZnCl2 and H2. Here also hydrogen gas is given. So of course this should be the answer, but how? Nitric acid is a strong oxidizing agent. Okay. So whatsoever hydrogen is formed, no issues, we will add oxygen to that. That's the work of HNO3 to produce water. So no longer you will have hydrogen, but you'll have water. Okay. Yeah, the composition of aqua regia. So aqua regia, if you see this 3:1, 3:1 is the same. Is it dilute and concentrated or concentrated and diluted, or what is that? That's the point. Both are concentrated. Both should be like highly concentrated so that it can dissolve gold. Gold is least reactive, so to dissolve that least reactive metal element, you require something really strong, so both will be concentrated. Okay. Which of the following are not ionic compounds? Ionic compounds, okay. So KCl, if you see, there will be K plus and Cl minus, and NaCl, if you see, it will be Na plus and Cl minus. If you see these two things, these two elements, they are not ionic. Okay. HCl and CCl4 are not ionic. You can find covalent bonds over there. So it will be 2 and 3. Okay. Next, which one of the following properties is not generally exhibited by ionic compounds? Not exhibited. Solubility in water. Okay. Electrical conductivity in solid state. Can anything conduct electricity in solid state? Nope. So this is not generally exhibited by an ionic compound. In aqueous state, they'll dissociate into ions, and those ions will conduct electricity. Not in solid state, where they don't exist as ions. Okay. Which of the following metals exist in their native state in the nature? Native state in the sense they are not found in any combined states. They're just found normally. Okay. Is it copper? Is it gold? Is it zinc? And is it silver? See, gold and silver you'll just obtain purely in the nature. Okay, they are not combined with any other things. Just you'll find some dust and all of that, which will be cleaned, and that refining will take place. So silver and gold. Okay. Yeah. Metals are refined by using different methods. Which of the following metals are refined by electrolytic refining? In electrolytic refining, highly reactive metals are used. Okay, highly reactive metals: silver, copper, sodium, potassium. Sodium and potassium are highly reactive. They are in the top of the reactive series, so it should be this. Okay. Next, silver particles become black on prolonged exposure to air. This is due to the formation of, we'll be thinking that okay, in air we have oxygen, so add oxygen. No, it won't form oxide. It's actually Ag2s. Ag will react with H2s, okay, to produce Ag2s. This is the reason, not this one, okay. Yeah, galvanizing is a method of protecting iron from rusting by coating a thin layer of zinc. This we know it from first. Zinc is the coating, okay. So now we'll do this 15th question and get this video done, because we'll do the rest of the question in the next videos, okay. Stainless steel is very useful material for our life. Stainless steel iron is mixed with. So this you can remember with a trick. If you remember the 24th element, chromium, then manganese, then iron, then cobalt, then nickel, okay. Iron is there, leave this and leave this, so it will be chromium and nickel. Chromium and nickel are found with it. Where is it? First option, chromium and nickel. These two are mixed, okay. This is a trick you can remember like this. And yeah, this is for today. I hope the video was helpful for all of you. So definitely spread the key of success and spread knowledge. Thank you.